Hi everyone, my name is Brian Handy and I'm an engineer with Aws App Config, and I'm here today to talk to you about how teams at Amazon rapidly release features at scale using Aws App Config. So what are you going to learn in this session? First thing is, what is application configuration? Configuration is a really overloaded term in our industry, so this is just a quick textbook style definition of what application configuration is. Next, we're going to look at some of the common problems that developers face while deploying application configuration. These are the types of problems that we've seen over decades of managing large-scale software at Amazon, and that we've seen our customers have as well. Then we're going to show you the best practices we've developed within Amazon for managing and deploying configuration, and how you can take those best practices and apply them to your applications as well. And then lastly, we're going to take a look at a demo that utilizes all of these best practices within a modern application for deploying application configuration. Picture this. You're a developer at a mid-sized startup working on a team of about 8 other developers. As a dev team, you guys are really on a roll. You're using the latest and greatest tech stack. You don't have a lot of ops burden at this point, and you have CI/CD pipelines set up, which is great because your customers have a lot of requests, so you're rolling out new features and maybe sometimes some bug fixes just about every day. So one day, you and the dev team are having lunch, and everything's going fine. And then the on-call engineer's pager starts going off. This isn't abnormal. You've been paged plenty of times in your career, but at the same time, you guys are a new product, and you don't really get paged that often, and when you do, it means that one of your early adopter customers is impacted. So maybe you're a little bit worried, but you're not the on-call engineer, so you stay behind to finish your lunch while the on-call engineer goes back to the office to try to figure out what the problem is. Well, about 15 minutes later, everyone's pager starts going off. Now you're a little bit more worried, and maybe a little bit irritated, because now you're going to have to leave your lunch and go back to the office. But sometimes that's what you got to do. So that's what you do, and when you get back to the office, you ask your on-call engineer, what's going on? They say the app's entire website is down and they can't figure out what the problem is, so they need the rest of the dev team. Now you're a little bit more worried. Maybe even panicked, you might say at this point. But even though it's stressful, you've been here before, so you get on your workspace, you start looking at metrics and logs to try to figure out what the problem is. About 15 minutes later, your company's CEO comes in and she wants to know what the problem is. Well, at this point, you don't really know what the problem is, so you say the only thing you can say, which is that the website is down and we're trying to figure out the problem. Obviously, she's not really too happy with that answer, but she sees that you're doing your best, so you don't really push it. So she doesn't really push it. Okay, that's just a little bit more pressure for you now that you've got your CEO hanging over your shoulder, waiting for you to fix the problem. But you keep looking through metrics, and eventually you stumble upon your database graphs. So you see that over the past hour, the IOPS for your database have been spiking, as have errors coming from your database. So you think that that's probably related. So you pull on that thread a little bit, and you go higher up the stack, and you see that requests to your API have also spiked during that period. Okay, that's probably related. So you dig into that more, and looking into your request logs, it looks like all of the extra requests are coming from one customer. Now, at this point, you don't know if this customer is a bad actor or if they have a genuine use case. But you're pretty sure that when you guys launched, you would put some throttling code into your service so that no customer could call your API more than a defined rate to mitigate situations like this. You haven't looked at that code since you launched, but you think you should probably find it and see if there's something wrong there. So after a little bit of grepping, you find that code again, looking through it, it jogs your memory, and you're trying to make sure that everything's set up there correctly. It looks like it is, and after looking through it, everything looks fine, but you remember that there's a separate configuration file where you actually define the values that show how many times each customer is able to call your API. So you go to that configuration file to make sure everything is fine there as well. Well, it looks like there was a change to that file 2 days ago. So you pull up the diff for that commit, and it looks like the developer who made that commit accidentally changed things so that every customer can call your API 1,000 times per second. This change was snuck in with a feature pull request that was a couple pages long, and nobody noticed the accidental couple line change to the small configuration file that no one had touched in a couple months. So now you're pretty sure you found where the problem is. So you change the values back to what they were before, you submit a pull request, you get it reviewed by your colleagues, and then you push it into your team's pipeline. It gets built into the pipeline, it gets tested, it gets deployed to your dev stack, it gets deployed to your pre-production stack, it goes through integration testing, and then it gets built into production. As soon as it gets built into production, you see IOPS for your database go down, requests to your API go down, and your website is back up. So at this point, you're feeling pretty good because you pretty much single-handedly mitigated this incident. On the other hand, you're not feeling so good because between the time it took for your on-call to get paged, for the rest of the team to get paged, for you guys to get into the office, for you to root cause the issue, for you to make the change, and then for your change to get built from your workspace to production, your website was down for about 2 hours. So you're not especially happy about this because it was not good for your customers, and neither is your CEO. All in all, you guys lost a good amount of revenue today, and all the customers who tried to access your website during this period would have had a bad experience. So, question for the audience is, do you think that this team could have done anything to prevent these errors from happening in the first place? And once they happened, do you think that this team could have done anything to mitigate them faster? Spoiler alert is that the answer is yes. I'm going to show you how AWS could have helped you to do that. So before I do that, let me take one big step back and do what I said I was going to do at the beginning and set up some context and define what application configuration is. Okay, so let's use the example of the application in this past story. So you're building an application that recommends restaurants to your customers. So you probably store some data for each of your customers where the unique identifier is their email address. Then you store things like their password, the restaurants they've been to recently, their favorite restaurants, etc., etc. Also associated with each customer, and globally, you have configuration data. So something like the throttling configuration that caused this issue. Although this configuration data is also scoped per customer, unlike the customer data that you store, this configuration data changes how your application behaves at runtime relative to each customer. And there we have the textbook definition of what configuration is, which is data that changes the behavior of your application at runtime. Okay, so what are some common application configuration use cases? And this comes with a big asterisk because we've seen about 1 million different ways to utilize configuration, and that's probably not even half the ways our customers are doing it. But these are just 3 of the most common ways that we've seen teams use configuration. So the first way is feature flags. Feature flags are essentially a way to gate and release your features separate from code deployments. So as an example, you could deploy all of the code for your feature one day and put it behind a feature toggle that's currently off, so hiding your feature. And then afterwards, you could set up all of the product-related materials, so your press releases, your Twitter announcements, what have you, and schedule them for release at, say, 3 p.m. on the coming Friday. At 3 p.m. on that Friday, when your press releases are set to go out, you can flip your feature flag to on and instantly release your feature to 100% of your customers globally, synced up with those product releases. The second common way that we see teams use configuration is for managing throttling and resource configurations. So similar to the example we just talked about, it's very common for teams to store throttling information or other resource limits within configuration. The third common use case we have is user onboarding and allow listing. So if you're an application that's not open to the world and is instead only accessible by a specific set of users, it's very common to store that specific set of users within a configuration file. So how do teams generally manage application configuration data? Well, there's 2 patterns that we typically see. The first and most common pattern that we see is managing application configuration in code. Probably the reason this is most common is our first advantage, which is that it's simple. You add a couple lines of configuration, or you add a separate configuration file as you're developing your feature, and it takes you a couple extra minutes and you're on your way. The second advantage is that you can take advantage of all the best practices we've learned over the years for deploying code and apply that to deploying your configuration. Since you're bundling your configuration with your code, that means that your configuration also deploys alongside your code, so it takes advantage of those same safety benefits. Now, the drawbacks to managing your configuration code are also connected to the fact that now your configuration deploys alongside your code. First of all, this means that deploying your configuration is slow. If you're managing a global application, it can take hours or days, or if you have any problems in your pipeline, even weeks to deploy code updates worldwide. And it'll take the same amount of time to deploy your configuration updates. The second disadvantage is that you can't decouple configuration deployments from your code deployments. Let's use an example to illustrate this. Let's say you're managing user onboarding through a configuration. And right now you're onboarding about 20 new users a week. And you expect this to, say, double year over year. So next year you'll be onboarding 40 new users a week. This means that every time a user wants to onboard to your service, you'll need to make an update to your configuration and then propagate that change throughout your entire code pipeline to your application. This means that every user will need to wait the hours or days or maybe longer to be onboarded to your service. And for your team, that means that you're now responsible for completing 20 additional code deployments a week worldwide to your application. And next year, it'll be 40, and maybe the year after that, it'll be 80. It's not a good experience for your customers, and at some point, it becomes untenable for you. The other drawback is that it's difficult to distinguish configuration errors from code errors. Let's use our example from the story from before. So in this example, your website was down, and you didn't know what the problem was. Initially, you thought it was a problem in your code. It turned out, after looking into the issue for a while, that it was an issue in your configuration. But how would you have known that at the start? You couldn't really have. If you're deploying your configuration updates at the same time as your code updates, there's no way for you to know what caused the issue if one occurs. And the only way to figure it out is to really root cause the issue, which increases your time to mitigation. Our last drawback is that changes to your configuration are now difficult to roll back. Since you can only deploy your configuration as fast as you can deploy code, this means you can also only roll it back as fast as you can roll back code. So the second pattern we see is managing configuration in a separate database. And sometimes teams will also build separate systems around these databases as well to help them manage these configurations. So the advantage of this approach is that it's fast. Unlike the previous example, where it took teams managing configuration and code hours or days or weeks to deploy configuration updates worldwide, if you're managing your configuration in a database, you can change one value or multiple values in a database and have that update be propagated worldwide in a matter of seconds. So the first drawback of this approach is that it requires operational effort to maintain and scale this database. Similar to every database that you own for customer data, you'll need to spend effort setting up monitoring, maintaining this database, and scaling it. And if you set up any other separate systems around this database, you'll also need to spend effort maintaining and scaling those as well. The next drawback is that, similar to how you can deploy configuration updates in seconds, you can also cause outages in seconds. So if a developer on your team updates a configuration in your database and they make a mistake, similar to how you can deploy a good configuration update globally in seconds, you can also deploy a bad configuration update globally in seconds and cause a global outage almost immediately. And then lastly, because when you're no longer managing your configuration and code, you're no longer able to take advantage of the safety best practices integrated into deploying code. There's no built-in monitoring when deploying your configuration updates, and there's also no ability to roll back automatically or manually built in. The only way to roll back is to change the value in the database back to what it was before. And if you have a stateful application, that might not even really do it, and you might have to take more drastic action to roll back your application to the state it was in before. Okay, so Amazon has seen these problems over a couple decades of operating large-scale software, starting back from the time when Amazon was a small grayscale bookstore, back when I didn't even know how to read yet, up until today. And particularly, we've seen the disadvantages of each pattern, and we wanted to create a solution that took all of the advantages of each pattern and cut out all of the disadvantages. So what we came up with was AWS App Config. App Config is a fully managed service for managing and deploying your configuration. App Config is, first of all, fast. It enables you to deploy your configuration anywhere in the world in seconds. App Config is scalable. It scales to the size of any enterprise, no matter what kind of capacity you're running on, without any effort on your part. And App Config is lastly, and maybe most importantly, safe. App Config offers you the ability to validate your configuration, to deploy gradually, to monitor the deployment of your configuration, and to roll back the deployment of your configuration instantly. So how do you actually use AWS App Config? Well, there's 4 steps. So the first step is to create your configuration. App Config gives you several possible options for creating your configuration. The first option is using AWS App Config hosted configurations. This is essentially App Config's built-in configuration store. Think of it like a database specifically built for storing your configuration. Using this, you can create and manage and deploy your configurations all from within App Config. Additionally, App Config offers you the ability to reference configurations stored at other services, namely Amazon S3, AWS Systems Manager documents, and AWS Systems Manager parameters. So after creating your configuration, the next step is App Config allows you to set up validators and monitors for your configuration. Let's start with validators. So before deploying your configuration, App Config will attempt to validate your configuration content against this list of validators. And if any of your validators determine that the configuration content is invalid, App Config will not deploy that configuration. There are 2 separate types of validator that you can define and attach to your configuration. The first type is a JSON schema validation. Basically, this is a type of validator where if you have a JSON or YAML configuration, App Config will attempt to check if your configuration content conforms to the schema defined within your JSON schema validator. If it does, then App Config will proceed with the deployment. If it does not, App Config will stop the deployment before it begins. This can be used to basically establish type safety and do syntactic validation prior to deploying your config. The other type of validator that App Config offers is an AWS Lambda function validator. This is a Lambda function that you can define that App Config will call on your behalf, sending the configuration content before deploying. Within this Lambda function, you can take the configuration content, perform any validation work that you want, and then send a validation result back to App Config. Based on this result, App Config will either proceed with or stop the deployment of your configuration. So after you set up validators for your config, you can then set up monitors. Monitors are basically a list of CloudWatch alarms where App Config will monitor each of these alarms during the deployment of your configuration, and if any of these monitors triggers during the deployment, App Config will automatically roll back your configuration to its previous state. Okay, so after you've set up validators and monitors, it's time to deploy your configuration. App Config gives you the ability to deploy your configuration as fast or as slow as you need. You can deploy configuration globally in a matter of seconds, or you can deploy your configuration gradually to an ever-increasing percentage of your application hosts. After your configuration has been deployed to 100% of your hosts, App Config offers you the ability to establish a baking period of time. During this baking period of time, Your configuration is deployed to 100% of your application hosts, but App Config will continue to monitor the alarms that you've attached to this configuration, and if any one of them goes off, App Config will instantly roll back the deployment of your configuration. And then lastly, if needed, App Config offers the ability to instantly roll back the deployment of your configuration. As we already said, during the deployment of your configuration and during the baking period afterwards, if any of the monitors that you attach to your configuration are triggered, App Config will instantly roll back the deployment of your configuration. Additionally, if you decide to at any point, you can manually trigger a rollback that will also complete instantly. Okay, so you can use App Config to manage and deploy configurations quickly, scalably, and safely. So what else do developers need for managing and deploying configuration in a modern application? Well, they need build and test automation. Developers want to be able to manage their configurations within a source repository, check that configuration in, and have it automatically built and tested. Then they want that configuration to automatically be deployed across however many regions their application is in without any effort on their part. And they probably want integration testing to be run between each of those regions. Basically what developers want is modern CI/CD best practices, which are typically applied to code deployments, applied to configuration deployments as well. So how do we get those CI/CD best practices and integrate them into deploying configurations with App Config? Well, we use a service that already has all of those best practices in AWS Code Pipeline. AWS Code Pipeline now offers you the ability to manage your configuration through a source repository, like AWS Code Commit, and then automatically build that configuration, test it, and deploy it across many AWS regions or applications or environments using AWS App Config. So now that I've talked through how to manage and deploy configurations using AWS App Config and how to bring CI/CD best practices to deploying that configuration using AWS Code Pipeline, I'm going to show you a demo of a modern application that uses both of these services to deploy its configuration.
Okay, so before we get started, let me just give you a quick breakdown of what we're going to be building today. And I'll note that all of this code will be available on GitHub, so if you want to follow along or you want to try it out for yourself, you can download the code and do that. Okay, so what we're building is a static website where the assets are hosted in an S3 bucket and served by Amazon CloudFront. Then we're also going to be utilizing AWS Lambda at the edge, Amazon Cognito, and AWS App Config for authenticating and authorizing users. When a user attempts to access our website, Amazon CloudFront will redirect the request to our Lambda at the edge functions, which will authorize the user with Amazon Cognito, and then we'll pull an allow list configuration from AWS App Config. If a user is not present in the allow list config pulled from AWS App Config, our Lambda at the edge function will send the user to a temporary page stating that our website is not yet available and inviting them to subscribe for email notifications of when the website launches. Let's take a look at what this looks like in practice. Okay, so to show that this works, first I'm going to try to sign into our website with an account that has been allow listed for access while we're in the beta phase. So as you can see, as soon as I go to our website's domain name, I'm directed to sign in through Amazon Cognito. So I sign in. And I'm able to make it to our website's landing page. Now, let me show you what happens if I attempt to sign in with an email address that hasn't yet been allow listed by App Config. In this case, I'm again prompted to sign in through Amazon Cognito. So I enter my credentials for my user that has not yet been allow listed. And you can see that instead of being redirected to our company's landing page, I'm redirected to a form that says we will be launching soon and offers me the option to subscribe to get notified when our website does launch. So now let's look at the solution a little bit from under the hood. Okay, so on the application side, I have a single repository set up which contains all of the CDK infrastructure code written in TypeScript, all of the Lambda at the edge function code, and all of our static website assets. Using this approach, we can make commits to a single repository and have them automatically built into our pipeline and then deployed to our dev stack, our pre-production stack, and our production stack. Now, in the future, after we launch, we'll probably add more deploy stages in other regions to better serve our customers around the globe. And we'll probably also add more testing stages between these deploy stages to increase our confidence in our code changes. That being said, even now, deployments are a little bit slow since we need to deploy a lot of infrastructure to CloudFront, S3, Cognito, and App Config on every deployment, as well as moving the assets into the correct S3 bucket. So, when we want to allow list new customers and onboard them to our application, we want a much faster method of updating that configuration. On the configuration side, we also have a single repository that contains our allow list configuration, and we'll look at what this looks like in a minute. Unlike our application pipeline, after committing changes to that repository, we don't need to build them, as it's simply configuration data. Like our application pipeline, we have a deployment stage for our dev stack, our pre-production stack, and our production stack. Unlike our application pipeline, instead of taking an hour or more to deploy changes across all our stacks, it takes about a minute or two to deploy changes through this pipeline. Now let's look a little bit more under the hood at how we're using AWS App Config. Okay, so now that we've seen how we're creating and deploying our configuration using AWS Code Commit and AWS Code Pipelines, let's see how we're setting up our validation and monitoring for our configuration. Let's start with validators. So we have two validators attached to our configuration. The first one is a Json schema validator, which essentially validates that our configuration conforms to the expected schema, namely that it has two properties. One, a list of allow listed email addresses, and the second, an allow public access boolean that, when set to true, will allow all access to our website and essentially launch it publicly. Now, this is important because since we're attempting to deserialize this config in our Lambda at the edge function, it needs to conform to the schema that we expect, otherwise we could see unexpected errors at runtime. Now, let's look at our second validator, which is an AWS Lambda function. Let's go look at the code for that. Now, this Lambda function can be used to do semantic validation as opposed to the syntactic validation done by our JSON schema validator. Looking at what this function does, we can see that it parses the list of allow listed email addresses, and if we're not yet allowing public access to our website, it checks to see that each email address belongs to an authorized domain. And the reason we do this is so that if an engineer or an operator makes a mistake and allow lists an email address that's associated with a non-authorized domain, so not an internal email address and not from a company that we have a non-disclosure agreement with, that App Config will stop the deployment of that updated allow list configuration and not allow us to accidentally expose our website before it's ready to parties who could disclose information. Okay, now let's go back and look at the monitors for this configuration. Okay, so we have a single monitor associated with our configuration, and what this monitor does is it will go into alarm if we have any increase in errors from our Lambda at the edge function. Now, we don't expect to have any increase in errors from this function due to a change in our configuration, since we know that by the time our configuration gets to this Lambda, it will conform to the proper schema, so we don't expect any errors parsing it. But no one ever said distributed systems were easy, so this alarm is just in case, and if there are any errors while we're deploying our configuration, App Config will automatically roll back the deployment of that configuration due to this alarm. Okay, let's fast forward a little bit to the day that we're launching our website publicly. So in order to do this, I'm going to modify our allow list config, which again is stored in a code commit repository, and I'll edit this directly through the code commit UI. And to launch our website publicly, I'll simply change this boolean allow public access from false to true, and then commit this. Okay, so as soon as I commit this, we can see that our code pipeline instantly begins deploying this across our stacks. In just a minute or two, we should see it update all of our stacks. Let's wait and see. Okay, So now, in just a little under a minute, that allow list configuration change has propagated to all of our stacks. Now, if our product team had any announcements, any Twitter announcements, or an email to send to our subscribers to send out to announce the release of our website, they could now do that now that our website has been published for everyone. Now, let's go make sure that this works. Okay, so as soon as we go to our website, I'm again prompted to sign in through Cognito. Now, I'll use the same email address that we used before that had not previously been allowed listed to use this website. And now that we've opened public access to the website, it looks like this email address and all other users that were previously not allowed listed to access the website can now access it. Thank you all very much for watching.
All right, thank you everyone. I hope you've learned how to use AWS App Config in conjunction with AWS Code Pipeline to quickly, scalably, and safely manage and deploy your application's configurations.